Hey everyone, welcome back to the channel. Today we are solving LeetCode 1 to 5 valid palindrome. This problem is a great example of the two pointers pattern, which is very commonly asked in interviews. We will understand the problem clearly, break it down step by step, and then implement it cleanly. Let's start by understanding what a palindrome actually means. Feel free to adjust the playback speed as you like. First, let's understand what a palindrome is. A palindrome is a string that reads the same forward and backward. For example, madam forward is madam backward. Now, for this specific problem, there are two important rules. We ignore uppercase and lowercase differences, and we ignore symbols and spaces. Only letters and numbers matter. Now let's simplify the problem using the given input. The string is a man, a plan, a canal, Panama. The problem clearly tells us what to ignore. We ignore spaces, we ignore symbols, and we ignore case differences, meaning capital A and small a are the same. After applying these rules, we check whether the resulting characters form a palindrome. One very common way to solve this problem is shown here. We start with the original string, then we clean it by removing spaces and symbols and converting everything to lowercase. After cleaning, we get this string: a man, a plan, a canal, Panama. Next, we reverse the cleaned string and compare both strings. Since they are the same, the string is a palindrome. This approach works correctly, but it uses extra space. Let's understand why this approach is not ideal. To solve the problem this way, we create a cleaned string and then we create a reversed string. That means we are creating new strings in memory. This increases space usage to O of n and also duplicates work unnecessarily. So, while this approach is correct, it is not space efficient, which is something interviewers care about. To avoid creating new strings, we use a better approach: two pointers. We keep the original string as it is, place one pointer at the start and another pointer at the end. We compare characters directly from both ends and skip anything that does not matter. This way, no new string is created and no extra memory is used. Now let's initialize our pointers. The left pointer starts at index 0, which is the beginning of the string. The right pointer starts at the last index of the string. From here, both pointers move inward towards the center. Throughout this process, we never create a new string. This step is very important. If the character at the left pointer is not a letter or a number, we simply skip it. Similarly, if the character at the right pointer is not alphanumeric, we skip it as well. We do not remove these characters, we only move the pointers. That's why the rule is skip, don't remove. After skipping spaces and symbols, both pointers land on valid characters. Now we compare these two characters. Since we are ignoring case, capital A and small a are considered equal. We compare characters only when both pointers point to valid letters or numbers. Now let's understand the complete logic using this flowchart. We will walk through it step by step exactly the way the code runs. We start here. First, we initialize two pointers. Left starts at index 0 and right starts at index n-1. Now we enter the main loop. The first question we ask is left still less than right? There are two possibilities, yes or no. If the answer is yes, we continue checking characters. First, we check the character at the left pointer. If S left is not alphanumeric, we do not compare it with anything. We simply move the left pointer forward and go back to the loop condition. This is the skip do not remove rule. If the left character is valid, we then check the right character. If S right is not alphanumeric, we move the right pointer backward and again we go back to the loop condition. Only when both characters are valid, we compare them. If the characters do match, we move both pointers inward. Then we repeat the entire process from the loop condition again. If the characters do not match, we immediately stop. At this point, the string is not a palindrome, so we return false. If the answer from the main loop, that is the condition where we are checking left is less than right, if this is no, that means the pointers have crossed. And if the pointers have crossed, all comparisons are done, so we return true. So this loop keeps running until either we find a mismatch or the pointers cross. This flowchart is exactly what our code will follow step by step. If you understand this flowchart, the code becomes straightforward. Now let's summarize everything we just saw in the flowchart. First, we initialize two pointers, left at the beginning and right at the end of the string. Then, while left is less than right, we keep repeating the same steps. We skip any character that is not alphanumeric. When both characters are valid, we compare them by ignoring case. If at any point the characters don't match, we immediately return false. If they do match, we move both pointers inward and continue. If the loop finishes without any mismatch, we return true. Now let's look at the pseudocode version of the same logic. This pseudocode is a direct translation of the flowchart we just saw. We start by initializing the left and right pointers. Then, while left pointer is still less than the right pointer, we keep looping. Inside the loop, we first skip any character that is not alphanumeric. Only when both characters are valid, we compare them by ignoring case. If there is a mismatch, we directly return false. If they match, we move both pointers inward and continue. If the loop completes, it means no mismatch was found, so we return true. Now that the logic is clear in pseudocode, the code becomes a direct translation. Let's implement this on LeetCode. This is LeetCode 125 valid palindrome. The problem asks us to check whether a given string is a palindrome after ignoring non-alphanumeric characters and ignoring case. So we do not compare spaces, symbols or punctuation. Only letters and numbers matter. In the example, you can see that once the string is cleaned logically, the remaining characters read the same forward and backward. We already covered this logic in the slides. So let's focus on the implementation. Let's quickly look at the constraints. The string length can be large, so we need an efficient solution. That's why we avoid creating new strings and use the two pointers approach with constant extra space. So we will solve this using two pointers. One pointer starts from the beginning of the string and the other starts from the end. We initialize left at index 0 and right at the last index of the string. We loop as long as the left pointer is less than the right pointer. This condition also naturally handles empty strings and single character strings. So if the character at the left pointer is not alphanumeric, we skip it. We use Python's built-in isAlnum method, which returns true only for letters and numbers. We move the pointer forward and continue to the next iteration. We do the same check for the right pointer. If it's not alphanumeric, we skip it by moving the pointer backward. Now both pointers are on valid characters. Before comparing, we convert both characters to lowercase, so case difference does not matter. If the characters don't match, we immediately return false. If the characters match, we move both pointers inward and continue checking. If the loop completes without finding a mismatch, it means the string is a valid palindrome, so we return true. This implementation directly follows the pseudocode we discussed earlier. No extra strings are created and we only use 2 pointers. Let's run the code. It ran successfully. Let's submit the solution. The solution is accepted. Now let's quickly dry run this code to see how it behaves step by step. Now let's dry run the algorithm with an example that is not a palindrome. Here both pointers are already on valid alphanumeric characters. When we compare them, the characters do not match. According to our pseudocode, the moment we see a mismatch, the algorithm stops immediately. So we return false and this string is not a palindrome. Now let's dry run an example that is a palindrome. Both the left and the right pointers are pointing to alphanumeric characters. When we compare them and ignore case, capital A and small a are equal. So this comparison passes. According to the algorithm, we now move both pointers inward. Left moves forward and right moves backward. Now the left pointer lands on a symbol. Since this is not an alphanumeric character, we do not compare it with anything. We simply skip it by moving the left pointer forward. And we continue. Now both pointers are again on valid characters. We compare them and they match. So once again we move both pointers inward. Now both left and right pointers point to non-alphanumeric characters. So either we can move the left pointer forward or right pointer backward. In this case, we are going to do left pointer forward. At this point, the left pointer crosses the right pointer. That means all required comparisons are done and no mismatch was found. So this string is a palindrome. Now let's quickly look at some edge cases. If the string is empty, it is considered a palindrome. If the string has only a single character, that is also a palindrome. If the string contains only spaces or symbols, once we skip them, there is nothing left to compare, so it is treated as a palindrome. But if we encounter an early mismatch, the string is not a palindrome. All of these cases are handled naturally by the loop condition. Now let's look at the time and space complexity. The time complexity is O of n. This is because each character in the string is visited at most once by either the left or the right pointer. The space complexity is O of 1. We do not create any new strings or extra data structures. We only use 2 pointers. Let's quickly recap the pattern we used. We placed 2 pointers, one at the start and one at the end. We skipped characters that did not matter, compared valid ones and moved both pointers inward. This is the two-pointer pattern, and it helps us solve problems efficiently without extra space. Now it's your turn. Try applying this two-pointer pattern to similar string and array problems. Focus on pointer movement and skipping conditions, not on writing extra code. The more you practice this pattern, the more natural it becomes. Let's quickly recap what you learned today. You learned how to check if a string is a valid palindrome by ignoring spaces, symbols, and case. You learned how the two pointers pattern helps us compare characters efficiently without creating extra strings. And you learned how this approach gives us O of n time and O of 1 space complexity. Thank you for watching. If this video helped you to understand two pointers better, please consider liking the video. You can also subscribe to the channel for more interview-focused explanation like this. And don't forget to click the bell icon so you don't miss the next video in this series. I will see you in the next one.